Hello everyone, welcome to my channel. You are learning with Dr. Shobha Nikam. In this video, I'll tell you how to convert BCD, that is binary coded decimal numbers, into the numbers which are compatible to 7-segment display. So 7-segment display is an electronic device which consists of 7 LEDs. For every segment, 1 LED is used. So total number of LEDs are 7. You know the general structure of LED. It has two terminals, anode and cathode terminal. So here in 7-segment display, the LEDs are connected like their cathodes are shorted. All the cathodes are connected to ground terminal and then they are called as common cathode display. If their anodes are shorted and they are connected to VCC, then it is called as common anode display. So see, all cathodes are shorted to ground. So the LED whose anode will receive 1 will turn on and remaining LEDs will remain off. So let's say I wanted to display 1. For that I wanted to turn this B on and C on, and suppose display is common cathode display. So all cathodes are already shorted to ground. What I'll do, I'll connect anodes of this LED B and LED C to 1 and remaining anodes I'll not connect them to 1, so that only these two LEDs will turn on and this 7-segment display will display number 1. To show 0, what I'll do, except G, I'll connect all anodes to VCC. Whereas in common anodes, the terminals which I wanted to blink or to turn on, what I'll do, I'll connect their cathodes to ground and anodes are already shorted to 1. So in this way 7-segment display works. But here how many segments we have, or how many LEDs we have? We have 7 LEDs. Which numbers we use in day-to-day life? We use decimal numbers. So first step is to convert these decimal numbers into binary. They are called as BCD. So they are from 0 to 9. So first step is BCD conversion. Then we need to convert these BCD numbers into 7 segments. So here this is our BCD to 7-segment decoder. It will convert BCD numbers into numbers which are compatible with this 7-segment display. So let's write down truth table for, let's say, for common cathode. So see, this is my table for BCD. Here A is MSB and D is LSB. So numbers are from 0 to 1001, that is 9. Now see, for 0, to display 0 on this 7-segment display, which LEDs will blink? Except G, all LEDs will blink or they'll turn on. This is common cathode display. So cathodes are already connected to ground. Now we need to set value of anode. So what we will do, we will connect anode of this G to 0 and all other anodes to 1, so that except G, all LEDs will turn on. Now next is 1. 0001 is 1. To display 1, what we need to do is we need to connect this B and C, anodes of B and C to 1, and other anodes we will connect to zeros. So this is 1. So this is 0, this is 1. To display 2, what we will have to do? For 2, A is on, B is on, G is on, E is on and D is also on. Only C and F are 0. So C is 0 and F is 0. Others are 1. So this is 2. Then for 3, E and F are off. So I'll connect E and F to 0 and others are connected to 1. So that is 3. Next is 4. To display 4, I'll display it in this way. So A, E and D are off. A, E and D are off and others are on for 4. For 5, B and E are 0. B and E are 0 and others are 1. For 6, B will remain off and others will turn on. So only B is 0 and others are 1 for 6. What about 7? Only A, B and C are on, remaining are off. So A, B and C are 1 and remaining are 0. That is 7. For 8 all LEDs must turn on. For 9, this E will remain off and others will turn on. E is off and others are on. So this 7 segment display can display numbers from 0 to 9. To display 10, we need to take 2 7 segment displays. One will display 1 and other one will display 0. So it can display numbers from 0 to 9. Now we need to design a circuit which will, for these inputs, will give us these outputs. So for that we need to prepare K-maps. K-maps for output A, B, C, D, E, F and G. So total 7 K-maps we will have to prepare. And for those K-maps, inputs are 4. So for 4 inputs, we will have to take a K-map with 16 cells. So let's start with A. So these are 7 K-maps for 7 outputs. So this is for A, B, C. This is for D, E, F and G. Then we use gray codes in K-maps. So here 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1 and 1, 0. So see here number is 0, 0, 0, 0 is 0, 0, 0, 0, 1 is 1, 0, 0, 1, 1 is 3, 2, 0, 1, 0, 0 is 4, 5, 6, 7. Here it is 1, 0, 0, 0 is 8, 9, 10, 11, 12, 13, 14 and 15. Here also 0, 0, 0, 1, 1, 1, 1, 0. So let's start with A. So we'll first put values of A. So see here numbers are from 0 to 9 only. So after 10 it is don't care 10, 11, 12, 13, 14 and 15 because BCD numbers are from 0 to 9 only. So after that any value is don't care value. So for A, values are 1, 0, 1, 1. So here 1, 0, 1, 1, 1, 0, 1, 1, 0 and then all ones 0, 1, 1, 1, here also 1 and here also 1. Now next step is we'll have to make groups. So we will try to make group of more and more number of ones. So here what we can do is we can make a group of these 8 ones. So these 4 are ones and these 4 don't care. So we will consider them as 1. So octal. Here also for these 2 ones what we can do is we can make group of these 8 horizontal ones. So first we'll write equation for this vertical one. A is equals to, here group is this vertical 8s. So here it is because here nothing is common and here value of D is 1 and 0. So values are different whereas C is 1 here and here also it is 1. So C plus for this group it is B is different and A is same. So A plus now see 2 ones are remaining. This one and this one is remaining. So what we can do is we will make this chord of adjacent ones. So here the equation becomes for this, here B is same, so B and here D plus B D plus one more one is remaining, this one. So there is no adjacent one. So what we can do is we can make groups of overlapping ones. There are ones at all 4 corners. So here what is same? This value of A is 0, 1. So can't take A. B is 0, 0. So B bar because value is 0. So whenever value is 0, we take bar of that variable. And here D is 0, 0. So B bar, D bar. So C plus A plus BD plus B bar, D bar. Similarly, now let's substitute values for each K-map. For B, we'll put values of C. So what I'll do, I'll first put values of all these K-maps and then we'll make groups. I have substituted these values from this truth table. Values of B, C, D, E, F and G. And values are up to 9 only. So for all remaining values, I have marked remaining cells as don't care cells. So let's find out equation for B. So for B, what we can do is for these 4 ones and these 4 ones. So we'll consider these two don't cares as 1. See, it is designer's choice to consider don't care as 1 or 0. So this is one octant. For that, the equation will become B bar. B bar plus these two ones are remaining. So there are no adjacent ones. So what we can do is we'll make 2 more chords. So this is my first chord and this is my second chord. Equation for this chord is here values of C and D are 0, 0. So C bar, D bar, and for this chord values of C and D are 1, 1. So plus C, D. So equation is B bar plus C bar, D bar plus C, D. Here for C, we can do, we can make this group, first group. Now these 3 ones are remaining. So for these 2 ones, we will make this group. We'll try to make group of more number of ones so that our equation will get reduced and we need less number of gates to implement it. So for this octant, first we'll write equation. So here C is 0, here C is 0. So equation is 0, 0 C bar plus for this B is 1. So B plus, now this only 1 is remaining. So what we can do again, we can use the ones which are already grouped. So we'll make this octant and for this it is D plus D. See, here it is C and here also it is C. But this is capital C and this is my small c. This C is for LED and this C is for BCD's input. Now let's find out equations for D, E, F and G. D, E, F and G. This group, first group. Then for this one, there are ones at all 4 corners. Okay, first we'll write equation for this. So equation for this is A, because here B, value of B is different and here all values are different. A plus. Now for this chord, it is A is different, B is 0. So B bar and here D bar, B bar, D bar plus. Now 3 ones are remaining. So what we can do is for this one we can make this chord, and for this chord equation is C D bar plus. Now these 2 ones are remaining. So for this one what we can do is we can make either pair or chord, but chord is always better. So I'll make this chord. So for this chord, here A is different, B is 0. So B bar and here C is same, B bar C. This is B bar C plus this one is remaining. So what we can do is we can make this pair, because there is no, we can't form a chord here. So for this pair here value of B is 1. So B, and here it C is 0, D is 1. B, C bar, D. Now let's find out equation for E, F and G. So for E, I'll make this group. chord, and equation is for this C D bar plus. Now I have two more ones. So what I can do is I'll check whether other two corners also have one. Yes, there are ones. So I'll make one more chord, and for this chord equation is A is different, B is 0. So B bar, and here D is also 0. So B bar, D bar. For F we can say this vertical chord. So this is one chord. Equation for this chord is C bar D bar plus these three ones are remaining. So here group of these 8 ones, and equation will become A plus. Now these two ones are remaining. So we can make this chord one chord. For this one chord equation is B, here B is same, and here C is same. So C is 0. So B C bar plus this one is remaining. So you can make pair, but if you make pair, number of variables will increase, but you have an option of making overlapping chord. So here B is same and here D is same. So B D bar. First group, and equation is A plus. For these two ones, vertical chord, and the equation is C D bar plus. For these two ones, this chord, and equation is B C bar plus. Now only one is remaining, so here we can make overlapping chord, and equation is B bar, and here it is C, B bar C. See, now somewhere you may form different group and your equation may vary, but you will get same answer. See here, what I have done, I have made this vertical chord. Instead of that, this one is already used. What you can do, you can make group of these two ones and these two, then your equation will vary, but ultimately your answer will remain same. So in some book, if you will find some different equation, don't think this is wrong or that is wrong. It is designer's choice. The equations may vary. If your grouping will vary, equation will definitely vary, but answer will remain same. So now I'll write down all these equations on one paper. So these are the equations for 7 segments. Now let's draw the diagram, or let's draw the circuit. So I have 4 inputs, A, B, C and D. Let's start with A, LED A. So for LED A, the equation is A plus C plus BD plus B bar D bar. So you can minimize it to B, X nor D. In that way also you can implement, or by taking 2 AND gates also you can implement. So see here, one OR gate. So I'll draw one OR gate. And output is A. What are the inputs to my OR gate? First input is A. Second input is C. Then next is BD. This is BD plus B bar D bar. So this is nothing but X NOR gate. So I'll simply draw one X NOR gate, XOR and then bubble. And the inputs are B and D. B and D. Or what you can do is, you can take 2 AND gates also here. So this is my A. Similarly for B, I need one OR gate and 2 AND gates. Or this is again C bar D bar plus CD. So this is nothing but C X NOR D. So I'll take one OR gate. Output is B. First input is B bar. So I'll take B I'll connect inverter here. So this becomes B bar. So one input is B bar and other is C XNOR D. So I'll take XNOR gate and inputs are C and D. So C is my first input to my XNOR and D is my second input to my XNOR. Then next is C. So for C, again one OR gate and inputs are C bar. So I'll take C, I'll connect inverter here, I'll get C bar plus B plus D. So this is C. Similarly, you can draw for D, E, F and G. So this is for D. Here for D it is A plus B bar D bar plus C D bar plus B bar C plus B C bar and D. Similarly here you can draw for E C D bar plus B bar D bar F and G. So after implementation of this circuit, when you will apply some BCD number as an input, you will get its 7 segment equivalent. So your circuit will work like this. For these inputs, you will get these outputs. So use of BCD to 7 segment decoder is to convert BCD number into 7 segment number. And applications of this circuit is in computerized clocks, counters and clocks, adding machines, computerized meters. In all these applications, this BCD to 7 segment decoder is used. Or wherever you see the 7 segment display, even in lift, when you press button 1, when you lift reach to 1, it will display 1. So there also this circuitry is used. Thank you so much for watching. I hope this will be helpful to you. Share this video with your friends and colleagues and don't forget to subscribe. Thank you so much for watching.